So the last tier of coupling is that of this idea of loose coupling. So with loose coupling, what we have is this very optimal state of communication between modules. So in this situation, we're only having very pertinent information being passed from one module to the next. So they're very loosely coupled together, meaning we could sort of change one out for another one and there wouldn't be a big problem. Maybe we'd need to change a line of code here and there to make it work, but it isn't going to be this giant project. Also, we're not going to have that problem of those weird cascading bugs all over the place because the train of data being passed is going to be very easy to track. Now, what we're not aiming for is no coupling. So there is this category of no coupling, but that just means that there's no communication between modules. Or maybe we just have one really, really, really large module. So, this module that just has information all the way down it. It's completely and totally crazy. And you can already, understand that that would be a problem too, is to just have a single module and be like, yep, there's no coupling here. That's a problem. That's an anti-pattern. That's what we call an anti-pattern, which is the opposite of a productive pattern. And it'll also break what our next tenet is, which is cohesion, because this would not have a singular purpose. This would have basically the purpose of the entire application. So that's also not what we want to do. So no coupling is not where we want to head. That's no communication whatsoever. And our modules, they need to talk to each other. They need to communicate in some way. There needs to be linkage between them. So that means we're sort of left with these two areas of coupling. And that is going to be the idea of data coupling and the idea of message coupling. So with data coupling, what we have, it's when two modules share or pass the same data. And what that means is that we just have data in one and we're passing it to another data or another module. We're passing that data to another module. Remember when we were talking about putting a getter or a setter? Well, for the setter, what do we have to pass? We have to pass data to set the information over here in this module. That's a passing of data. That's a linkage between the two. If we change the data over here, something's going to change over here. If we decide that we want to pass a different type of data over to B, well then that's going to we might have to make a change over in B to accept that new type of data. So even though the change would be small, there'd only be a little line of code there to change, there is still a tiny amount of linkage. However, we can't really get past this because modules have to communicate. We have to be able to pass data from one end to the next. So this coupling is not bad. This is just sort of the optimal state of coupling. Again, there's going to be a little bit of it, but that's perfectly fine. The other idea is message coupling, and that is when messages or commands are passed between modules. And what we mean by this is if maybe we have, this is our initializer, so we have an app and this initializes the app. And then maybe down here, we have, maybe this starts the background services or something. And then this calls into this is going to be the notification manager. This over here is maybe the backup manager. This over here is potentially, I don't know, maybe like some backend calculations. So calculation, just calc for short right there. And so you can see this is actually a pretty good setup here. We have an init. It calls down to a command to start up the background stuff. The background stuff then partitions it very smartly to the background calculator task, the background backup task, the background notification task, and those all start up and they pass commands on. They're telling, B is telling this to operate every 12 hours, this to operate every 3 hours, this to operate every 14 hours, et cetera, et cetera. They're commands being passed. They're messages. They're saying, hey, C, you should begin this task. Hey, D, you should begin that task. They're not going into the nitty gritty. They're not controlling. Remember, that's the difference. This is not control coupling, meaning we're passing flags into each one of these to change the control. We're just telling it what needs to be accomplished. So in this situation, we're telling it the calculation process should run. And then this figures out, given on the set of parameters in the current state of the app, what that means. And same with the backup. We're not passing commands, we're not passing flags, we're just telling it, do the operation that you're supposed to do. And then the backup manager will do that, just that. It'll look at the state of the app and it'll do its job. It'll back up the state of the app to wherever it needs to go. And so that is what message coupling is. And you can see with the combination of message coupling and data coupling, we can create any application that we need. We don't need any of that other coupling to basically work our application or our program in any way, shape, or form. well, given a little bit. There is some situations where you're going to need to maybe couple it just a little bit more. Maybe if you coupled it just a tiny bit more, maybe you went up to the medium coupling for a section of your application, it might save 200 hours of work, or it might actually be more maintainable. And those situations are fine. But our objective here, our idea is we want to get as loose as possible. We want to reduce the web of dependencies within our application. And so that is the sort of the objective of all this, our loose coupling here. Again, we don't want to go with no coupling. We want this idea of loose coupling.